Okay, we've made it all the way to lesson 3.5, and so the things that you need to assemble for this lesson would be your video notes, that's the sheet I gave you, and a note card. We're going to write things about this on one note card, and then perhaps some scratch paper so that we can do a few fraction problems on scratch paper. So the deal is, we've already looked at the graph translation theorem, and that's when we had the rules where we had capital T, x comma y, and maybe we said something like x plus 3, y minus 7, where we told that every ordered pair was going to slide 3 to the right and 7 down, right? And so if we applied that to maybe, let's apply it to the parent graph of the square root of x. If we applied that to the square root of x, inside our grouping symbol we would do the opposite of what our rule said, and then outside we would do, do the same, so I'll make that a negative 7, okay? So that's going to go 3 to the right and 7 down, isn't it? Okay, well the graph translation theorem is for sliding points, so all the points of a particular figure, left and right horizontally, and then up and down vertically. Well, we can also do something similar with the graph scale change theorem. When we talk about scaling something, we're talking about multiplying it by a scale factor. So when you were in geometry class and you learned about, maybe you had a triangle that was a 3, 4, 5, and you had another triangle over here that was a 9, 12, 15, then you looked at that and you said, well, 9 compares to 3 in that it's 3 times as large, 3 times 4 is 12, and 3 times 5 is 15. So you had a scale factor of 3, right? And so we're going to do that kind of an idea on scaling all kinds of different functions. So on your note card, I want you to write this information down that's right here. It says for lesson 3.5, we're going to call it the graph scale change theorem. The graph scale change theorem says this. Instead of using a capital T for translation, we're going to use a capital S for scaling. And it says the scale change x comma y is going to equal not adding or subtracting, but a times x and b times y. So we're going to take the coefficient of x as a multiplier and the coefficient of y as a multiplier as well. If we apply that to the graph of y equals f of x, then you replace y with y divided by b, and you replace x with x divided by a. So in this equation right here, we're going to take this y and replace it with y divided by b. We're going to take this x right here and replace it with x divided by a. So that's what the graph scale change theorem says we're going to do. Now, you might think, well, that seems confusing to me. I don't know why we're dividing. Well, that's because when you go from the rule to the grouping symbol, remember when we were doing the horizontal translation? We had to do the opposite, didn't we? Well, that was an inverse operation. Adding 3 and subtracting 3, those are inverse operations. Well, the inverse of multiplying is dividing, so that's why we're going to do dividing there. Okay, now once you get all that written down, there's a few other little things that you might want to know, and they are these 3 things. If the scale change x comma y presents itself with a negative sign in front of the x, so put a negative in front of the x, then that function is being reflected over the y-axis. So an example of that would be, let's say I had this parabola, and I had a negative sign in front of my rule, well then it would become a parabola here, reflecting over the y-axis, wouldn't it? Okay, if I have s x comma y, or the scale change x comma y, and I have a negative on my y right here, then I'm reflecting that over the x-axis. So again, let's say I had this little parabola, then it would be coming down here reflected over the x-axis. All right? So we'll see some negatives come up in some of those rules, and then that's going to add additional information onto the rule. And then, if we have the scale change x comma y, that is ax, by, and a and b are equal. So that would be something like a scale change where you had, for instance, 3x comma 3y, the same multiplier here as you do here. Then that's just called a size change, because if we use the same amount of stretching or shrinking all the way around the object, both x and y, then we're just going to change the size of it. Okay? All right, well that's all that we need to put on the note card, and I'm sure it may not be all that clear what's going on or how we're going to use that note card, but I'm going to have you grab a piece of scratch paper and I'm going to flip you over to something that we did earlier, because you can see we're going to be doing a lot of dividing. So 1, oops, let me get my pen turned on. Okay, if I had 1 divided by 1/6, we had that for a homework problem the other day, that's the same thing as 1 divided by 1/6, so 1 times 6 gives us 6, isn't it? If you have 5 divided by 1/3, that's the same thing as 5 divided by 1/3 written this way, or 5 times the reciprocal 3, which gives you 15, right? So if you have x divided by 1/2, it could be x divided by 1/2 this way, that's the same as x times 2, and that's going to give us 2x, isn't it? So if you have x divided by 2/5, x divided by 2/5 is the same thing as x times 5/2, isn't it? So you could write that as 5/2 x, or you could write that as 5x over 2. What if you had x divided by negative 3/4? Well, that would be the same as x divided by negative 3/4, so x times negative 4/3. When you invert to multiply and you reciprocate a fraction that has a negative, then you're just going to want to keep that negative in the numerator. It wouldn't be wrong to put it in the denominator, but you would just probably want to keep it in the numerator. You can call that negative 4x over 3, or you could call it negative 4/3 x if you'd like. Okay? And we're going to be doing a lot of that where we have a number or a variable and we're dividing by a fraction. And I just wanted you to get up to speed on that because that's going to be a skill that we'll use to work on your video notes page. So the next thing I want you to get is your video notes page. On the video notes page, it says that we are going to find the transform equation of the given equation under the given scale change. So in this problem, it says remember to make your little stacked fractions. I call those stacked fractions where we stack them and we write y divided by b and the x divided by a. So in this problem right here, we're going to consider this to be ax comma by. So the first thing I want you to do is to take the rule and identify what is a and what is b. So the a in this case is 1/2 and the b in this case is 1/3. A is always the coefficient of x and b is always the coefficient of y. Now we're going to apply it to this parent graph, and you can see as you look at the first 6, we're using all different kinds of parent graphs to apply this to. So we could apply this rule to any of the parent graphs. Alright? We're going to write this as y divided by our b value is equal to x divided by our a value, but then we're applying this to the quadratic, so we're going to put parentheses around the whole thing and square it. Now, you're not going to be allowed to have any complex fractions in any of your answers. And you see that both the left-hand side and the right-hand side of this equation have complex fractions. Let's just follow order of operations and let's just simplify it using that. So let's not mess with the left-hand side for now. Let's come over to the right-hand side, go inside the grouping symbol, and ask yourself, what's x divided by 1/2? X divided by 1/2 is the same thing as x times 2, isn't it? So that becomes 2x. But we still have to do what to it? We have to square it. So by order of operations, I'll come over here. We have y divided by 1/3 is equal to 4x squared, isn't it? Okay, now, you probably are thinking about, well, why can't I just do y divided by 1/3 and turn that into y times 3 and make that 3y? Well, you can, but you'll have 3y is equal to 4x squared. And then you're going to wind up right back around multiplying it both sides times 1/3, aren't you? So what you want to do is really get rid of this number on the bottom multiplied by whatever it is. It could be a fraction, it could be an integer, it could be a whole number. Just multiply to get rid of it. So we're going to wind up with the end result being y equals 4x squared over 3. You could also write that as 4/3 times x squared if you want to. All right. So, number 2. This is our rule, ax comma by. We're going to apply this to y equals x cubed. So this time we're applying it to the cubic. In order to do that, I'm going to have to identify my a value, which is 1/5, and then my b value, which is -4. All right, we're going to take y divided by b, x divided by a, but don't forget after we divide by 1/5, we have to cube this, don't we? All right, so we're going to leave the left-hand side alone for now. What's x divided by 1/5? X divided by 1/5 is the same as x times 5. That's going to give you 5x, but we still have to cube it, don't we? We still have to cube it. Okay, so if I do that, I'm going to wind up with y divided by -4 equals 125x cubed. Now, to get rid of that -4 in the denominator, I'm going to multiply both sides by that. I'm going to come up with y is equal to -500 x to the third. So that's my transformed equation. All right, on number 3, we have our ax comma by. And so we're going to say that a is equal to 5 and b is equal to 4. So y divided by 4 is equal to big gigantic square root x divided by 5. Okay, now we don't have any complex fractions here, do we? And so we might think that we don't have to do any kind of simplifying and we would be done, except for getting rid of this 4 over here. But you might recall the rules of radicals say that we cannot have a radical that contains a fraction. So we are going to have to work on this a little bit. Let's just leave the y divided by 4 over here and split this apart. We'll have the square root of x over the square root of 5. And then do you remember what you need to do? You need to rationalize the denominator. So we're going to multiply numerator and denominator by square root of 5. So we're going to wind up with y divided by 4 equals, we can multiply these together, so the square root of 5x, and then the square root of 5 times the square root of 5 is 5. All right? So now, we're going to multiply both sides by 4, and this is going to wind up to be 4 times the square root of 5x all over 5. Or you could write it as 4/5 times the square root of 5x if you would like. All right, on number 4, we have an a and we have a b. So we're going to say a is equal to 3/2 and b is equal to 7. So y divided by 7. Now look at your function this time. This is the exponential function. So this will be y, not y, 5, sorry about that, raised to the power of x divided by 3/2. Okay? So you want to ask yourself, what would x divided by 3/2 give you? X divided by 3/2 is the same as x times 2/3, isn't it? Okay, so we're going to rewrite this as 2/3 x. Okay, we're going to multiply both sides by 7, and we're going to wind up with y equaling 7 times 5 to the 2/3 x. What you don't want to do is you don't want to multiply the 7 and the 5 together because they have different bases, so we're not allowed to multiply those together. So this would be our final answer. Okay, let's try number 5. Our parent graph this time is going to be the hyperbola. We'll see if we can figure out the a and the b. Okay, it might be kind of tricky to know what the a is right here, but this is the rule. So this is like the fraction 1/5, isn't it? Like the fraction 1/5. So a is 1/5 and b is -4. So we're going to take y divided by -4 equals 1 over x divided by 1/5. So now I have the ultimate complex fraction over here, but let's start on the bottom down here. X divided by 1/5 is the same as x times 5, isn't it? So rewrite it over here. We'll have x divided by -4 equals 1 over 5x. And then to get rid of that -4, we're going to multiply both sides by -4. We're going to wind up with y equals -4 over 5x. All right, number 6. Here's our rule. Ax comma by. A is equal to 1/9. B is equal to 6. We're going to apply this to the cube root function. The cube root function. So y divided by 6, the cube root of a big gigantic cube root, x divided by 1/9. Dividing by 1/9 is like multiplying times 9. Now, if you had something in that radical that could be simplified, something you could take the cube root of, you could take it out of there. Like, let's say you had a 27x in there. You could take the cube root of 27 and reduce it. But we don't have anything that's a perfect cube in 9 or x, do we? Now we're going to multiply both sides by 6. So we're going to wind up with y equals 6 times the cube root of 9x. That's going to be our final answer. Okay. Now another skill they want us to be able to do is to go the other way. If they give us the rule, give us the equation, can we work backwards and find the rule? And the answer to that is sure. Okay? I like to call this the stacked fraction. So if this is mirroring y minus b and f of x divided by a, then we could easily pick out, because the coefficients of x and y are each 1, we could pick out that the a value is 3 and the b value is 7. A is 3 and b is 7. Alright? So we want to write this rule, the scale change rule. And the rule is just ax comma by. So we would say 3x comma 7y. Alright? Now the next thing we're going to do is we're going to tell in words what the scale change is telling us in words. Okay? So we're going to say the graph of, and I really don't know what it is, I'm just going to say f of x, right, has been, okay, this a amount is what's happening horizontally. The b amount is what's happening vertically. If your a or your b are greater than 1, this is being stretched. Okay? It stretches the graph. If your a or your b lies in between 0 and 1, this is when you get compressed. The book talks about this as a, as a shrink. It'd be shrinking the graph down. So it'd be like looking at it, let's see, what would shrink something? The reverse of a microscope. A microscope would blow it up so you could see it bigger, or a magnifying glass would magnify it, but you would be shrinking it down. Kind of like a shrinky dink. If you ever make those when you were kids, and you colored on that plastic stuff, and then you baked it in the oven and it shrunk it down? It was a shrinky dink, and you could make all kinds of cool little sun catchers and stuff. Well, that would be a shrinking. Okay? So this one has been horizontally stretched. Horizontally because we're talking about the a amount, stretched because it's greater than 1, by a factor of 3. That's a multiplier, so that's a factor. And let's tell what happened vertically. Vertically stretched by a factor of 7. So it's going to be 3 times as wide on the horizontal and 7 times as tall. 3 times as wide and 7 times as tall. Okay, well let's try number 8 here. On number 8, we could rewrite this as y divided by 1 equals f of multiplying by 5/6 is like dividing by 6/5, isn't it? Dividing by 6/5. Multiplying by 5/6 is like dividing by the reciprocal. We can't have 5x over 6. We have to get that to a 1x, so we have to make that a 6/5. So the scale change rule would just be 6/5 A, oops, 6/5 x, sorry, A is 6/5, comma, and you could write 1y if you want to, or you can just write y. So basically nothing's happening to the height of it vertically, but it is getting wider because it has a 6/5 here that's bigger than 1. So we could say in words, the graph of f of x has been, we don't want to comment anything about vertically, just horizontally. So we're going to say horizontally. Okay, that number is larger than 1, so we're going to call it a stretch by a factor of 6/5. By a factor of 6/5. Okay, on number 9 then, we're looking at this 8 right here, and this 8's not part of that function with the x in it, is it? So we're going to have to take that -8 and move it over to the other side. So we can divide it off and move it back where it belongs. So this becomes y divided by -8 equals f of x divided by 1. So there's your a, and there's your b. So when we write our rule, we're going to write just 1x, or just an x, comma, -8, and then that would be y. Alright, so we actually have two things going on here, even though nothing's making it wider or thinner along horizontally, but we are stretching it, and then we have a negative sign that will have to indicate what kind of a reflection we're getting. So keep your note card handy that you made. We're going to say the graph of f of x has been, now nothing happened to it horizontally, we'll say vertically stretched by a factor of 8. We're going to use the 8 for the stretch because the negative sign means something different. And, okay, we're going to have an and here, reflected over the, when the negative's on the y, look on your note card if you can't remember, but it's being reflected over the x-axis. Okay? Alright, let's try to tackle this one. Multiplying by 1/6 is like dividing by 6. Multiplying by 1/6 is like dividing by 6. Multiplying by 2 is like dividing by the reciprocal 1/2. I have to get this to be a 1y. I have to get this to be a 1x. So my a value is 1/2. My b value is 6. The rule is 1/2 x, comma, 6y. 1/2 x, comma, 6y. Okay, so that means the graph of f of x has been, okay, now this is going to be horizontal, so horizontally, and then this time because we have a fraction, we're going to say compressed by a factor of 1/2, right? And vertically, that number is greater than 1, so that's a stretch. We're going to say stretched by a factor of 6. Okay? So we're going to make it half as wide and 6 times as tall. Half as wide and 6 times as tall. Okay, I'm looking at number 11, and what I notice about number 11 is I don't like that 5 where it is. That 5 is not part of the function f of x, it's not in parentheses, so I'm going to have to take that and I'm going to have to move it to the other side. Now you might think, well, I'll just divide it and get rid of it, but I think it might be easier if you multiplied by 1/5 here. Then you'll have y divided by 10 equals f of, multiplying by 4 is like dividing by 1/4. So a is 1/4, b is 10. The rule is 1/4 x, 10y. 1/4 x, 10y. So it's going to be 1/4 is wide and 10 times as tall. So we're going to say the graph of f of x has been, okay, now we'll talk about this first, horizontally, and then the 1/4 is a compression, all right? It's going to lie between 0 and 1. We're going to compress it. So we'll say horizontally compressed by a factor of 1/4, and vertically, that number is larger than 1, so we're going to say stretched by a factor of 10. So it's going to be skinny and it's going to be really, really tall, isn't it? Skinny and really, really tall. Okay, what do you notice that's wrong on number 12? Well, on number 12, we need to get rid of that, don't we? Okay, now we might have a little trouble getting rid of it, but let's multiply both sides by -4. So that's going to give us -4y over 3 is equal to f of 7x, right? All right, multiplying by -4/3 is like dividing by -3/4. So this multiplier, we're going to invert when we put it in our stack fraction here, okay? Multiplying by 7 is like dividing by 1/7, isn't it? So a is 1/7 and b is -3/4. Okay, so our rule would be 1/7 x, comma, -3/4 y. To tell what happened, the graph of f of x has been, then we have to tell this, this, and this. So horizontally, stretched, oops, it won't be stretched, it'll be what? Compressed by a factor of 1/7, and, well, let's put a comma because we got 3 things. We're going to say vertically, that fraction is less than 1, so that will be compressed to by a factor of 3/4, and last but not least, let's do that negative sign, and negative on the y is reflecting over the x. So we're going to say, and reflected over the x-axis. Reflected over the x-axis. All right, so that was a lot. You know, I'm going to tell you that the hardest thing you have to do in this whole chapter is get a handle on this, and it's just something that's not negotiable because it implies that we're going to, or it impacts everything we're going to do when we get to trigonometry. We're going to write stacked fractions with functions that are trigonometric, so it's really, really an important skill that you really, really, really want to get to know how to do well, and you need to understand what the sentences are telling you. Okay, let's work on the back side of the paper here for a little bit. All right, it says we're going to find the scale change rule for this equation. And notice the equation is almost in stacked fraction form. Y divided by 4 looks really good. But over here in the grouping symbol, then we need to get this written not multiplying by 6, but multiplying by 6 is the same as dividing by 1/6. It's asking us to find the rule. When it asks you to find the rule, you're going to start with f, x, comma, y. And that rule is going to be AX, comma, BY. So that means we're going to take this graph and we're going to compress it 1/6 as wide. We're going to stretch it 4 times as tall. So you're going to say the graph of y equals f of x. Now let's use absolute value of x. Y equals absolute value of x has been, we're going to say horizontally, and then we'll use the 1/6, so that's going to be compressed by a factor of 1/6, and vertically stretched, because that number is bigger than 1, by a factor of 4. By a factor of 4. Okay, on number 14 it says consider this parent function, which is the cubic, right here. Describe in words what the scale change would do. Well, this is your A, and this is your B over here, isn't it? So your A value is actually, I'll go ahead and write it down as a -2, and I'll say your B is 1, but you need to address these two things separately, the negative sign and the 2. So we want to describe in words what the scale change is going to be. Okay? So the scale change will be that the graph of y equals x cubed has been horizontally stretched, because again that number is larger than 1, by a factor of 2, and the negative sign is on the x this time, reflected over the what? In this case it would be the y-axis, wouldn't it? Okay, now I want you to find the equation of the image. So the equation of the image says we would take y divided by b, x divided by a, and cube it. Okay? Y divided by b, x divided by a, and cube it. By order of operations, we're going to cube first. Actually, y divided by 1 doesn't mean anything, does it? We're going to cube the numerator and cube the denominator. So that's going to be x cubed over -8, isn't it? So you could write that as y equals -1/8 x cubed. You could leave it like this if you want to. Both of these would be the same. All right. Number 15 says we're going to graph. This graph of this function below is given. And what we're going to do is we're going to graph with this. Now, these are kind of dicey, scary problems because whenever you have a problem like this, if you don't get the right rule, you're going to miss every single ordered pair that you're doing, and your graph will be completely wrong. So we have to be very, very vigilant that we're getting the correct rule as we go. So we have to write our stacked fractions. Y divided by 3 looks good over here. Multiplying by 2 is like dividing by 1/2. So our rule that we want to apply to this, all right, we're going to have the ordered pairs coming out of here, and they're going to get the rule of 1/2 x comma 3y, aren't they? Because that's our ax comma by. All right. That said, then we have to go figure out what are points A, B, C, D, and E. Okay, well the ordered pair for A right here is the ordered pair -6, 0. The ordered pair for B is -2, -1. The ordered pair for C is 0, 2. The ordered pair for D is 2, -3. And the ordered pair for E is 6 negative 3. All right, now we're going to run each one of those ordered pairs through the rule. So 1/2 times all the x coordinates, 3 times all the y coordinates. So my A prime point is going to be half of negative 6, which is negative 3, and then 0 times that 3 gives me 0. Okay, my B prime point, or my image of B, half of negative 2, and 3 times negative 1. My C prime point will be half of 0, and 3 times 2. My D prime point will be half of 2, and 3 times negative 3. My E prime point will be half of 6, and 3 times negative 3. And now what we want to do is we want to graph that on this piece of graph paper down here. So I've given you nice graph paper with a scale already written on there. So we have negative 3, 0. We have negative 1, negative 3. We have 0, 6. We have 1, negative 9. And we have 3, negative 9. Okay. We'll take a straight edge and we'll connect these in order. So A to B, so that's A prime, that one's B prime. Okay, B prime up to C prime. C prime to D prime. And then D prime to E prime. Alright, so the picture is supposed to look the same as it did in the beginning, only you can see how it's been compressed, so it's only half as wide as it used to be, but it's been stretched, so it's 3 times taller than it used to be. And that's a pretty good representation. The graph paper is probably not exactly the same scale, but it's pretty darn close. Okay. Number 16 says we want to accurately sketch the image of the graph of y equals x squared under this rule. Alright, and then it says find the equation of the image. So let's do that. Let's find the equation of the image. The A value is 1 and the B value is negative 3. We're going to apply it to this. So y divided by negative 3 equals x divided by 1 and square it. Okay, x divided by 1 is x, so x squared will be this side, so y divided by negative 3 is equal to x squared. Multiply both sides by negative 3, and our equation is y equals negative 3x squared. Okay, let's put some axes on here. And it wants us to accurately sketch the graph of y equals x squared. Okay, I think I'm just going to use negative 5 to 5. I can get it more accurate, I think. So 1, 2, 3, 4. Okay. So if I'm going to graph y equals x squared, and I'm looking for some ordered pairs for that graph, 0, 0 would be on it. 1 and plus or minus 1 would give me 1. And plus or minus 2 would give me 4. Okay, so let's see how good I can do with my pen here. Okay, so this will be the graph of y equals x squared. Alright, let me just get a different color pen here. Now it wants to do the other one, which is negative 3x squared. Okay, so let's put some numbers in for that. Well, 0 is going to give me 0 again. Plus or minus 1 will give me negative 3. Okay, so what should be happening with this? Well, if you wrote out the rule, the rule would be s, x, comma, y is equal to 1x, comma, negative 3y. So that's telling me I'm going to stretch it. Is it stretched by a factor of 3? And it's reflected over the x, isn't it? It's reflected over the x. So that looks pretty good, doesn't it? All right, and the last two problems. Let's define the scale change which stretches a graph horizontally by a factor of 4 and shrinks it vertically by a factor of 1/5. So again, we have to identify the A and the B, and they don't have to be in English when you type this up, or when the book types it up. They don't have to come always in the right order. So anything horizontal is your A, anything vertical is your B, isn't it? Anything horizontal is your A, anything vertical is B, but they could switch them up. Okay, so it says we're trying to find the scale change F. That means we're finding the rule. And the rule is simply going to be 4x, comma, 1/5 y. 4x, 1/5 y. Okay, and on number 18 it says the zeros of a function are at negative 12, negative 4, and 8, and the y-intercept is 16. So we have negative 12, negative 4, positive 8, and the y-intercept is up here at 16. Okay, so let's see what that might look like. Something like this, maybe. Some graph that looks kind of like that. So the zeros are the x-intercept, and the y-intercept is up here at 16. Give the x and y-intercepts for the image of the graph under this transformation. So here's your A, and here's your B. All right? Now, the A is the horizontal. On the horizontal, we find the x-intercepts, don't we? So the x-intercepts are all going to get compressed by 1/4. So my x-intercepts okay, the original x-intercepts are negative 12, negative 4, and 8. The new x-intercepts on this scaling are all going to be 1/4 that much. So 1/4 times negative 12, 1/4 times negative 4, and 1/4 times 8. So they are going to be at negative 3, negative 1, and negative 2. Wait a minute, that's a positive 8. So I'll do positive 2. Okay? So those are our new x-intercepts. This B value is your vertical scale factor. So the original y-intercept is at 16, and there can only be one y-intercept if we truly have a function. The new y-intercept will be negative 2 times that. So that will be at negative 32. Because what's going to happen to that function is it's going to be compressed, so a lot skinnier. So let me take my pen here and see if I can. It's going to be a lot skinnier because the y-intercepts are going to be at negative 3, negative 1, and positive 2. And then it's going to be turned upside down because this is going to be down here at negative 32, isn't it? So let's see, what would that have to look like? Something like that. Okay? So it's going to be stretched vertically, rotated, flipped over the x-axis with this negative sign right here, and then it would be 1/4, so smooshed up, not quite as wide. All right, there's a lot to have to handle in one lesson. I'm going to give you a big packet of homework to work on, and I'm going to show you some real-life examples of some scale changes when you get back to school in class the next time. But you need to really, really, really understand this well, because a lot of what we're going to do in the future is going to depend on whether or not you understand this stacked fractions and the division. So if you have any questions or concerns at all, please come and see me. If you didn't understand this, please come and see me, because we'll have to make sure that you get this when you get to class next time.